In this why do we care question, we're concerned about the health impacts of transmission lines and the magnetic fields that they create. Because remember, magnetic fields are created by moving charges. So if I have these big long transmission lines, I'm creating a probably pretty decent magnetic field on the ground. Okay? So we're constantly in it. We're constantly swimming in it. Is that dangerous? All right, we'll see. Currents in DC transmission lines can be 100 amps or higher. Some people are concerned that the electromagnetic fields from such lines near their homes could pose health dangers. For a line that has a current of 150 amps and a height of 8 meters above the ground, what magnetic field does the line produce at ground level? Express the answer in Teslas and as a percentage of the Earth's magnetic field, which is 0.5 Gauss. Is this value cause for worry? All right, so first things first, let's try to understand why this is even an issue. So here is, let's say, transmission lines, right? And so you have a current going from, one to the other, okay? And there's current of 150 amps that's moving this way, right? And as you remember, right, if there's a current moving this way, then there's a magnetic field that wraps around the whole thing. So there's like all these magnetic fields in circles around it, right? But these, they exist all throughout space at all different radiuses. So here, at this radius, there will be a B field at the ground, right? And that B field, remember, the B field due to a long current carrying wire is mu naught, the permittivity of free space, over 2 pi r. Okay? All right, so how do we solve this? Well, we know that mu naught is 4 pi times 10 to the minus 7. We know that our current in our transmission wire is 150 amps, okay? And the radius is, well, we're 8 feet from the ground and we want to find the B field at the ground level, right? So what is that? That is 8 meters. So I'll put in 8 meters here. If I put that all into a calculator, find an answer, I get 3.75 times 10 to the minus 6 Tesla, okay? But we want to compare that to 0.5 Gauss, okay? Now, Gauss is another unit for magnetic fields. Very easy to look that up. I don't remember the conversion off the top of my head, but there's many programs that will either do it for you or you just find the conversion and you do the latter method between the two. Very easy. I find out that when I put this magnetic field in Tesla and convert it to Gauss, I get 0.0375 Gauss. Okay? Now, how do we determine if this is dangerous for our health? Well, a long time ago, when humans lived on the planet before there was any kind of transmission lines, before we'd even learned to harness the power of electricity, all right, we all lived and bathed in a magnetic field that big from the Earth's magnetic field, okay? So this is the status quo. If this isn't harmful to us, then is this harmful to us? All right? Well, let's see. If we want to find out the percentage of this, of the power line to the Earth's magnetic field, then we would just take 0.0375 divided by 0.5. I get that that's about 0.08 or 8% of the Earth's magnetic field, okay? Pretty insignificant with respect to the Earth's magnetic field. If this were 800 times the Earth's magnetic field, maybe we would feel a little bit of worry that we're actually doing something harmful to our bodies. But the deal is, if we're already used to living in this, having something on top of that that's just 8% bigger, probably not a big deal, okay? I'm not saying that nothing humans do can be harmful to the world and to nature and to us, but I'm saying that there are clever ways to kind of assess the risks and to see how big different effects are relative to what's naturally already around us. With that said, I'll see you next week. Have a nice weekend.